Greetings to all of you. The session is regarding international entrance and competitive exams regarding the chemistry field, chemistry domain. And India is conducting JEE Advanced and JEE Mains examination all across India for the entrance into the technical domain, that is BTech stream. And NEET exam will be conducted, that is for medical entrance examination all across India. That exam will be conducted once in a year. Telangana and Andhra Pradesh government are conducting MSET examination for BTech entrance. That is again the technical domain. In addition, every time we will get the competitive exam for the government job opportunities where general studies question paper will be there. The kind of session what we are conducting will be very much fetching for your preparation. If you are seriously preparing for that, this kind of session will be very much helpful for your further preparation. Let's enter into our today's session. The question number 1 dealt with the Nobel Prize in the field of chemistry for the year 2004 was awarded jointly together Aaron Chaitznobor, Avron Hershko, and Erwin Rose for the discovery of ubiquitin-mediated protein degradation. Okay, so this is the esteemed prize all across the world. World recognition interval. By 3 scientists are together worked upon this protein-related research work, so that they are accorded with this. They are laureated with this Nobel Prize in the field of chemistry for the year 2004. This is about the description of who contributed for this esteemed work. Aaron Chaitznobor, Avron Hershko, and Erwin Rose together worked upon this protein degradation process. Our Royal Swedish Academy of Sciences has decided to award the Nobel Prize in the field of chemistry for the year 2004 for the discovery of ubiquitin-mediated protein degradation. And a brief info regarding all 3 scientists are provided over. Aaron Chaitznobor, technician, Israel Institute of Technology, Haifa, Israel. Avram Hershko, Technion, Israel Institute of Technology, Haifa, Israel. And Erwin Rose, University of California, Irvine, United States of America. These 3 scientists together worked upon this protein degradation process and catalytic conditions called ubiquitin. Let's see what is the work and why they are awarded with this Nobel Prize. Everybody aware the proteins are building blocks of all the living organisms. Even plants and animal organisms are composed by these proteins. In the past few decades, biochemistry has come a long way towards explaining how the cell produces all its various proteins. Protein synthesis, how efficiently protein synthesis is carried, and what way proteins are utilized for healthy growth of organisms. But a new perception got introduced by these 3 scientists together, that is breaking down of the protein. It is not the kind of degradation or discrimination, rather it is the kind of a useful pathway. After breaking the long chains of the proteins, they individually used for multiple applications. They again used to grow further, and they again used for the multiple applications. That kind of new perception got introduced by the scientist Aaron Chaitznobor, Avram Hershko, and Erwin Rose. And against the stream and beginning of the 1980s, they discovered the cell's most important processes got introduced over there. And the year 2004 Nobel Prize is accorded because of their outstanding work in the field of chemistry. Aaron Chaitznobor, Avram Hershko, and Erwin Rose have brought us to realize cell functions a highly efficient checking station over there, and how building up and breaking down both are possible together. How can we grow the protein further, or else a long chain can be broken and further they used to whatever fragments degraded, they used to grow further, and multiple applications we can notice with that's the reason why the kind of work is most outstanding. And we will get the kind of contribution in the field of chemistry. A label consists of molecule called ubiquitin. Ubiquitin is the having a catalytic activity over there. In order to enhance, always catalyst having the property to enhance the rate of reaction, so that fastens the protein degradation process, and again it can be recollected and reused. So that ubiquitin is the kind of a fantastic material can enhance the rate of reaction and can be reused further. That is the way it is working. So we are very much thankful for the work which is introduced by these three scientists together, which are laureated with the esteemed Nobel Prize for their outstanding work in the protein research, molecular level, cell controls, and number of central processes got carried over there. That's the reason why this Nobel Prize is accorded for these three together. So by this, we can conclude the question one and entered. Sorry, and here is the entire process of protein degradation, which is catalyzed by the ubiquitin material, and detailed description is provided for ER reference. We can go with the question number two, where it is collected from Cambridge International Education, and this is the question. The table shows the masses of some ions in 1,000 cubic centimeter for the toothpaste. If 1,000 cubic centimeter sample of the toothpaste is provided with you, these many number of ions you can notice over there, and their relative masses also provided in grams. Ammonium ion, calcium plus 2 chloride, fluoride, magnesium plus 2 phosphate, sodium monopositive, and sulfate stannous Zn plus 2 ions are present. And their masses in the grams per 1,000 cubic centimeter are also provided with you. So with this data, we have to go to solve whatever questions posed here. State which negative ion has the lowest mass in 1,000 cubic centimeter. Negative ions, here some negatively charged ions you can clearly notice among all. Negative ion has the lowest mass. So here the question is somewhat logical. So in general, among all the ions, 0.1 will be the correct answer, where this is for cation. But they mentioned with the negative ions. In case of negative ions with the lowest mass, we have to go for sulfate is the negative ion with the 9.2, and phosphate with the phosphate is the negative ion with 24.4. And either one is fluoride with the 1.4, chloride with a 0.9. So among all the negative ions, the chloride is the correct answer with the 0.9 grams of mass in this 1,000 cubic centimeter. So that you can mark this chloride as the right answer. Name the compound that contains ammonium and chloride ions together. Obviously, in this toothpaste only you can find this ammonium and chloride ions. Their respective masses also provided with you. So along with this, we can go with any other answer as well. Here you can clearly notice acidic nature and uses. Ammonium chloride obviously acidic in nature and finds applications in fertilizers. And it is used to grow the corn, wheat, barley, rice, because ammonia is very essential to grow the plants, and photosynthesis is most important. Nitrogen content, NPK, are the most important ingredients to grow the plant and give the higher yield of the product. So that ammonium chloride is the most essential fertilizer to nourish the crop yields and also increase the yield of that product as well. So this is the way we can answer the question number two. Move on to another question. Calculate the mass of phosphate in 250 centimeter cube of the toothpaste. Entire data is provided with 1,000 cubic centimeter. 1,000 cubic centimeter of phosphate is having 24.4. If 250 centimeter cube is there, what will be the answer? That is calculated by using this cross multiplication formula. 1,000 cubic centimeter is containing 24.4 grams of the phosphate, and 250 centimeter cube contains how much? So that you can multiply like this. 250 can be multiplied with 24.4, and this is divided with 1,000. So the 6.1 grams is the correct answer. This is the way all questions, whichever posed here, can be perfectly answered. Question number two got completed. Let's move on to another question number three. It's collected from JEE Advanced 2015 paper 1 question paper conducted by the National Testing Agency. The total number of stereoisomers that can exist in a imine. This is the compound which is organic moiety with the bicyclic ring system, and you can notice methyl functional groups. It is somewhat cloudy in nature, and simply we can say Narbonane type of compound, where you can clearly observe 3 methyl groups are there, and another ketonic functional group, carbonyl group, is also located on this bicyclic system. Total number of stereoisomers to be depicted. In order to identify stereoisomers, the possible criteria will be How many chiral carbons are there? What optical isomers are possible? In that way, we can go for calculation of all this. But in case of these compounds, the thing is somewhat different, because being it is a crowded one, so steric hindrance plays a role here. Because of high steric hindrance, we can't rotate, we can't twist, we can't tilt this molecule as we wish. That's the reason why it is somewhat rigid in nature. It is not moving anywhere. So that only the possible isomer for this one will be a mirror reflection. You can clearly notice, if you take the mirror reflection of this one, this is only the possibility. So though we are having bridgehead carbons, and this is a kind of corner carbon with a gem dimethyl, and here also chiral carbons are present, we are not supposed to go for the normal calculation of stereoisomers. Rather, only the possibility is a mirror reflection. Because of that reason, the existing number of isomers, stereoisomers for this non-Bornstein derivative will be only 2 because of steric hindrance, rigidity of the molecule. This is the way we can answer. Let's move on to another question, number 4. Again, it is collected from 2015 question paper of JEE Advanced. The number of resonance structures which are given for this in starting material is taken is a butanol, which is an organic aromatic alcoholic compound. Always aromatic alcohols are mild acids in comparison to the aliphatic. Aliphatic alcohols are generally neutral. Aromatic alcohols are acidic in nature, but acidity is somewhat less in comparison to the carboxylic acids. In the organic chemistry, carboxylic acids are the stronger, and aromatic hydroxy are comparatively weak acids. Though it is weak acid, but it can be comfortably reacted with sodium hydroxide and be able to generate the salt of sodium alkoxide. We can say sodium naphthoxide will be generated. So butanol, this is a butanol, can be treated with sodium hydroxide. It's a salt will be generated. Sodium naphthalene 2 oxalate. This is a IUPAC name of the compound. That is a product in. And naphthalene 2-ol is a IUPAC name of the starting material. Sorry for that. Right. So this compound will be treated with sodium hydroxide, giving rise to the sodium alkoxide salt. Whatever negative charge generated will be distributed all across the carbon atom, so that how extent we are going to contribute the charge among all the carbon atom, that extent stability of the compound will be increases, so that more the number of resonance structures, more will be the stability of the molecule. That we can say canonical structures as well. So that the negative charge existing on the oxygen can be delocalized in such a manner, and we can observe 9 possible resonance structures for the given alkoxide kind of material, so that 9 possible isomers we can notice over here. So the number of resonance structures for N will be 9. You can clearly observe all possible chemical structures of these resonance forms. By this, we completed question number 4 and move on to question number 5. The correct increasing order of the electronegativity is రుణవిద్యుదాత్మకత పెరిగే క్రమాన్ని సూచించండి. In order to answer this one, we have to go with the Mulliken scale of the periodic table. Mulliken scale is used to depict the electronegativity of all the elements. Individual element electronegativity values got calculated in the Mulliken scale. So that let's see the entire periodic table, which is accorded with the electronegativity values. This is the quantification of electronegativity values. Generally, if you are moving from left to right hand side, as we are ascending, the electronegativity values are gradually increasing. As the size decreases, electronegativity increases. And in a group, from top to bottom, gradually electronegativity values will be decreased. This is a general trend we can clearly observe. But within the problem they mentioned with boron, carbon, sulfur, and chlorine, if we observe boron accorded with 3.04, carbon with 3.15, and sulfur with 3.44, chlorine with 3.50. So all are arranged in a increasing order only. So that let me mention boron, carbon, sulfur, and chlorine. That the chlorine with the highest value, boron to chlorine can be arranged in the same order that is mentioned in option number 1. So that we can answer this question number 5. Option 1 is the correct answer in accordance with the Mulliken scale of the periodic table. Let's move on to another last question of the session. The pair of molecules with the seesaw and a linear shape will be. Uh, in order to answer this one, everybody should aware about the concept called hybridization. Based on the hybridization only, we can accord their geometry. According to geometry only, bond angles, bond lengths, bond energies, everything will be calculated. So that hybridization is most important to understand. ఈ క్రింది వాటిలో ఏ జత అణువులు వరుసగా తూగుడు బల్ల మరియు రేఖాకృతి జియామితిని కలిగి ఉన్నాయి. A pair of molecules with a seesaw and a linear geometry. Let's go with one by one. Methane and sulfur trioxide. Methane is called water tetrahedral geometry. Everybody aware about with the sp3 hybridization 109 degrees 28 minutes bond angle will be there for this methane molecule. Sulfur trioxide, where sulfur can be observed with the sp2 hybridization with the trigonal planar geometry. All sulfur oxygen bond angles are recorded with the 120. So planar triangle, we can clearly notice so that there is no correct mapping with this, cancel out. Xenon tetrafluoride and carbon disulfide. Xenon tetrafluoride is accorded with the D2sp3 hybridization, which is a square planar one with a 2 lone pair of electrons, so that it is not a seesaw one. Carbon disulfide, where carbon is in sp3 sp hybridization with the linear geometry with 180 bond angle. So we can't go with this linear. Linear is correct only, but first one is having square planar but not seesaw, right? So cancel this option 2 as well. If you go with SF4, where DSP3 hybridization, you can notice trigonal bipyramidal, we have to get it. Trigonal bipyramidal, but here we have only 4 fluorines with 1 lone pair of electrons, so that a molecule geometry is somewhat distorted, and we can accord with the seesaw geometry rather than that trigonal bipyramidal. One of the corner is occupied by this lone pair, so here distorted trigonal bipyramidal, which is said to be a seesaw geometry. And another is about a C2H2, which is called acetylene. Acetylene carbons are recorded with the sp hybridization, where linear geometry is always sp hybridization will accord the linear geometry with 180 bond angle. So that seesaw and linear is accorded with the sulfur tetrafluoride and acetylene molecule. We can say ethyne as per the IUPAC protocol. So option number 3 is the perfectly answer for this question number 6. And let's see the option number 4 as well. Carbon tetrachloride, again carbon is in sp3 hybridization with the 109 degrees 28 minutes bond angle, and carbon dioxide is accorded with the sp hybridization and a linear geometry. 180 bond angle will be there. Linear geometry is mapping, but seesaw is not accorded for this carbon tetrafluoride, right? So that you can cancel out option 4 as well. Only the existing answer for the question is 3. Let's see what is the possibility. Sulfur tetrachloride Lewis structure is provided over, where sulfur is accorded with 2 fluorides like this, 2 fluorides over there, and exact geometry is mentioned over. Lone pair of electrons are located at one corner, and the remaining 4 fluorides are mentioned like this. DSP3 hybridization with a trigonal bipyramidal existing geometry with 1 lone pair, so that it will be distorted into seesaw. This is for SA4, and move on to SA4. You can clearly notice 2 types of bond angles are possible. Equatorial fluorides are recorded with the 1 or 2 bond angle, and axial bond angles are having 120 bond angle. So this is a deviation from 120 bond angle, and 173 instead of 180. This is for axial. Equatorial bond angle is shifted to 1 or 2. Actually, it should be 120. Axial bond angle should be 180, but it shifted to 173. This is the kind of deviated one. So 102 and 173. Here you can clearly notice 173 and 102 bond angle is given for axial and equatorial bond angles for this SA4 seesaw geometry. Move on to another called acetylene, where carbon is participating in sp hybridization And sp hybridization obviously giving rise to the a linear geometry, carbon carbon joined together with the triple bond, and the terminal hydrogen with the sigma bonds, only single bond will be there, and bond angle will be 180 degrees. This is the way linear geometry is accorded for this one. And by this we entirely completed the question. For question number 6, option number 3 will be the right answer. Hopefully the session is very much informative, and we collected the information from the various platforms, various sources, and I'm very much thankful for all the information whichever provided by the valuable information provided for this kind of session. And we collected the information from various segments of the chemistry, included with the organic chemistry, physical chemistry, inorganic chemistry, and the problematic sessions also covered over application point of view. Entire kind of systems are covered, and informative session was conducted over there. And I'm sincerely requesting to like the channel. In order to comment, we have a question for the session. Question is related with the hybridization. Can you give an example related with the sp hybridization, sp2, sp3, dsp2 hybridization? Only 4 are mentioned over. Let me repeat one more time what will be the question to be answered for the session in the comment box. Give the examples related with sp hybridization, sp2 hybridization, sp3 hybridization, dsp2 hybridization. If anybody know these examples, you can put answers in the comment box and share with the aspirants who are more serious about the examination, and subscribe the channel. Definitely we will get the informative session in the near future. Thank you very much for your patient listening and kind support.